All right, good evening, algebra classes. Doing this video to sort of backtrack a little bit after talking to some people today. I kind of want to just backtrack on the basics of functions and maybe help you guys see the little picture and maybe the big picture that we've done on um, 1D, 1E will kind of make a little bit more sense to us. So I put this note sheet in there, functions, the basics. It's in the folder in Classroom. You can go find it. Um, let's just get back to the basics here. So a function is a relation of two variables with one output for each possible input. Okay, they want stuff. We know that. Okay, so in any function, we have our input, which is our x. Okay, our output is the f of x, which is just again your y value. Okay, so for every x value, okay, it's going to shoot out a y value, and that all is going to be dependent on what the function is. Okay, it's going to be dependent on what the function is. So each x is going to spit out a y, okay, based on how we calculate it. Okay. Now, a graph. Okay, I'm going to add this to the paper here as well. Okay, a graph is just a set of points. A set of points that represent function. Okay, so a graph is just a bunch of points. So the line is just a bunch of points. Okay, that represent the function. Each point is an x and a y on the coordinate plane. Okay, so if I have a linear function, okay, we know that the linear parent function is y equals x. So we'll just go y equals x. Now, we know that the domain is all real numbers. Okay, there's no restrictions on the domain. Okay, so the domain is all real numbers. So we have x, okay, and we have f of x. And they say that f of x, which is y, it is equal to x. Okay, so this column is also going to be x. So if my x is -3, my y is going to be -3. My x is -2, okay, my y is going to be -2 because y equals x. -1, -1, 0, 0, 1, 1, etc., going on down the line. Okay, so this function y equals x. So the points are going to fit this function where the y value equals the x value. So if the x is -3, the y is -3. If the x is -2, the y is -2. If the x is -1, the y is -1. If the x is 0, the y is 0. Okay? 1 and 1, and 2 and 2, and 3 and 3, and 4 and 4, and 5 and 5, and 6, 6. Okay? And coming down here like that. Okay? So that's all the possible points that fit on the graph. And there's more, and we can do an infinite number of inputs. Okay? But when we do the points where the y value equals the x value, we get a graph that looks like this. Okay? And so, again, this line is just a set of points. All right? And so we draw a line through all the points that fit y equals x. Okay? That's all. Y equals x. Okay? So from here, our domain is all real numbers. Our range is all real numbers. We have our x and y intercept right there because it goes through the point 0, 0. Okay, so that takes care of our intercepts. No axes of symmetry, no asymptotes, nothing of the sort. Okay, so it's just these sets of points. Okay, depending on what the function is going to change our set of points. Okay, coming down to number 2, we have our absolute value function. Okay, so our absolute value function is f of x or y is equal to the absolute value of x. Okay, we should know that absolute values is the distance of a number from 0. So we just take whatever numbers inside these bars right there and make it positive. Okay, so in this function, we have x. That's really ugly. So we have x and f of x. And again, it says f of x is equal to absolute value of x. Okay, so if our input x is -3, our output is going to be the absolute value of -3, which is 3. If our input is -2, our output is going to be +2 because we're taking the absolute value of x. Okay, 0, the absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. Okay? Pick your points. Pick your points. Doesn't matter. So on the absolute value thing, if we plot all the points on this thing, and you can make as many points as you want, so we have negative 3, 3. And we have negative 2, 2. Okay, and negative 1, 1. It's not there, but it's not in the graph, but it's there. And we have 0, 0. And then we have 1, 1. And then we have 2, 2. All right, hopefully we see the pattern. Okay, so we plot all these points as using what we know about absolute value mathematically. X is our input. We can use any input we want. There's no restrictions on absolute value. And we plug it into whatever the function is, which is absolute value, and it spits that out, giving us the absolute value graph that looks like that. Okay, so what this means, if we go to Desmos and we go, f of x equals the absolute value of x, look at what it does. It graphs that line. Okay, well, why does it graph that line? Because this red line takes all the points that would fit this little graph right here. Okay, negative 3, 3, negative 2, 2, 0, 0, 1, 1, 2, 2, because that's how you find the absolute value. The absolute value of x is your output. Okay, so look, we have negative 1, 1, and we have negative 2, 2, and we have negative 3, 3, and negative 4, 4, and 0, 0, and 1, 1, and 2, 2, and 3, 3, and 4, 4. Okay, so the line is just the thing that, holds all the possible points that make this equation true. Okay, so any point that is touching this line, the y value is the absolute value of the x value. So if I take a point here that's on a line, which is, negative 6.5 about, okay, I go up here, and then the y value is positive 6.5 there. So we're at, negative 6.5, comma, 6.5 at this point right there. Okay, so any point on this line, okay, fits into this table. Absolute value. Okay, now let's just look at quadratic real quick, and I just want to look at maybe 4 or 5 points here. So remember, quadratic, f of x equals x squared. Okay, again, the domain is all real numbers. The domain is all real numbers, okay, because we can square any number that we want. We could square any number that we want, okay? So x, y. So say we have negative 2, 1, negative 1, 0, 1, 2. Okay, now the y, which is our f of x, is equal to x squared. So we take our x and we square it. So negative 2 squared is positive 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. And so on and so forth. Okay? So negative 2, 4 is a point on this graph. So negative 2, 4 is a point. Negative 1, 1 is a point. 0, 0 is a point. 1, 1 is a point. 2, 4 is a point. 3, 9 is a point. Negative 3 squared is 9. Bang, is a point. So look at these points and look at the pattern. So it makes this U-shaped thing right here, this parabola. Okay? It makes that parabola. So when we go into our calculator and we say, f of x equals x squared, there's your parabola. Okay? So any point that we pick on a graph, okay, I don't know what this is here, where this point is, but we know that whatever the x value is, the y value is x squared. Okay? If let's say we just pick this random point right here. Okay? This random point. So the y value is, the x value is maybe negative 2, maybe negative 2 point something something. okay? And the y value is that negative 2 something squared, which is 5 point something something, okay? So again, this parabola has all the points, all the possible points that would fit in this table, okay? And again, we can use any x that we want. We can use any x that we want to plug in there, okay? So plug any x's in that you want, square it to get the corresponding y values, and so now we have our points. Negative 2, 4 is a point. Negative 1, negative 1, 1 is a point. That should be a 1. So negative 1, 1 is a point. 0, 0 is a point. 1, 1 is a point. 2, 4 is a point. 3, 9 is a point. Okay? And so this orange parabola is a line that encompasses all the points that this function would dictate there are. Okay? So every point on this graph, there's an x value and a y value, and the y value is the x value times the x value. All right, looking at the root. Okay, so f of x is equal to the square root of x. Okay, now again, remember, thinking about the domain here. Okay, y in our graph, we had the domain was, x is greater than or equal to 0. Okay, because if I made a table of values here with x and f of x, if I put in a negative number for x, I wouldn't be able to get a y. Okay, so if I go here and I go to Desmos Scientific Calculator and I want to do, I don't know, the square root of negative 6, undefined, error, doesn't exist. Okay, so I cannot take the square root of a negative number. Okay, so all the negative numbers are out. So when I go to graph this thing, or if I want to find some points, we just need to know sort of common sense wise that we can't square root a negative number. So on to our table. So let's just start with 0. And let's go to 1. And I'm going to go 4, 9, and 16. I know it's a little off the grid, but I just kind of want to get some points here without having to do a whole bunch of calculations, okay? So x is 0. F of x is the square root of x. Okay, so the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. Okay? And so now look at this graph, 0, 0, 1, 1. And then we have 4, 2. And then we have 9, 3. Okay, and then over here we'll have, 16, which is probably up here, 4, something like that. So the square root graph is going to end up looking like this when we plot those points. Okay, so every point on this graph, the y value is the square root of the x value. Okay, every point on this graph. So going to our calculator, our graph, okay, if we have f of x equals the square root of x, let me clear the screen here. There's our graph, okay, and we have our 1, 1, and we have 4, 2, and we have 9, 3, right? And we have, going forward, we have 16, 4, 25, square root is 5. So we have all those points there. So the graph sort of levels off like that, okay? I mean, it still goes up forever and ever, but the rate of increase kind of decreases over time, okay? But when the y value is a square root of the x value and you plot those points like we did, you get a graph that looks like that. So that's why we have these graphs, okay? You're just doing the simple calculation, taking the input, doing whatever it is that we're doing to it, which in this case is the square root, to get the output. And now you have a series of points, 0, 0, 1, 1, 4, 2, 9, 3, 16, 4. All right, so the cubic one, we have x, so y equals x cubed, right? So our y values are going to be whatever x is to the third power. So if we have x is -2, -2 times -2 times -2 is -8. If x is -1, -1 times -1 times -1 is -1. 0. 0 times 0 times 0 is 0. 1. 1 times 1 times 1 is 1. 2. 2 times 2 times 2, 8. 3. 3 times 3 times 3, 27. Okay? So we'd have, -2, -8 is a point. -1, -1 is a point. 0, 0 is a point. 1, 1 is a point. 2, 8 is a point. Okay? And then 327 is going to be way up here. So that's why our root graph looks kind of like that. Okay? So every point on this root graph, the y value is the x value cubed. Okay, whatever your x value is, go to your x value. Okay, so if I went to an x value, let's say of -4, okay, so -4 cubed, -4 times -4, 16, times -4 is -64. So -4 this way, I'd have to go down -64 that way to actually find my point on that graph. All right. I want to look at exponentials real quick because this one's kind of interesting, and we're going to learn more about laws of exponents later. But let's look at this one. So we have y equals 2 to the x power. Okay, so we're going to have x, and this is f of x, which is just 2 to the x power. All right, I'm going to take -5. I'm going to go -2. I'm going to go -1. I'm going to go 0, 1, and 4. Okay. So x -5. So we're going to take 2 to the -5th power. So let's just go to our calculator here. Desmos scientific calculator, if you're following along here. So we're going to take 2 and we're going to raise it to the -5th power. So 2 to the -5th power is 0.03. Okay, 0.03. So, so 2 to the -5th power. So -5 is our x. 0.03 is our y value. So it's really going to be pretty low down there. Okay, so I don't want to get this wrong. 0.03125. Okay, -2. Okay, well, if we go 2 to the -2nd power, back to our thing here. So if we go 2, we raise that to the -2nd power, we get 0.25 or 1/4. Okay, so 0.25. So if -2 is our thing, -0.25 or positive 0.25 is going to be right there. Okay, a little higher, but still pretty low. -1. So if we go 2 to the -1 power, 0.5, which is 1/2. So if -1 is our x value, our y value is going to be 0.5, which is right there. 0. Okay, we can take a 0 exponent. Any exponent of 0 is going to give us an answer of 1. Okay, so anything raised to the exponent of 0 is always going to be 1. So 2 to the 0 power is 1. So 0 is our x value. 2 to the 0th power is 1. So 0, 1 is a point. Okay, 1, 2 to the first power, we know is 2. 4. 4, I messed that up. No, I'm right. Yeah, so 2 to the first power is 2. Okay, for 4, now we're going to go 2 to the 4th power because we're taking 2, which is a constant, to the x power. So 2 to the 4th power. 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, so to catch up on our graph, we have the 0.12 here. And then we have the point 4, 16, which is kind of way up there. Let's say I want to stick a 3 in there. Okay, so we have 3. Okay, 2 to the third power. 2 times 2 times 2, 8. Okay, so 2 to the third power, 8. Okay, so we run this thing, and here's what our exponential function looks like. Again, we have an asymptote here, our horizontal asymptote. It's never going to be a negative number. It's never going to be 0. Can never be 0. Okay, crosses at 0, 1, because any exponent of 0 is 1. And it goes like that. Okay, that's why our exponential function looks the way it does. Okay, because we take any x value that we want, plug it into that thing, and raise 2 to whatever x power that we have. And now we get these points. Okay, so negative 5.03125 is in there. Negative 2.25. Negative 1.5. 0, 1. 1, 2. 4, 16. Take any point you want. Go to the calculator. Okay, so if y equals 2 to the x power, there's your graph. Every point on this graph is 2. The x value, excuse me. So any point that we have on here, we have our x value and 2 to the x power. While my phone's going off here. Sorry about that. And so any point here, whatever x value we have, you're raising that 2 to that x value power. Okay, I'm going to skip the logarithmic one for right now. Hopefully we're kind of getting the hang of this. We'll talk more about logs later, but we kind of know what the logarithmic function looks like there. Okay, rational. Now we know with the rational function, x cannot equal 0. Okay, and so remember the rational function is f of x equals 1 over x. F of x equals 1 over x. X cannot equal 0, so we're not even going to bother putting that in the thing. So x and f of x is 1 over x. So let's say x is negative. Let's say we have negative 5. Let's say we have negative 2. Let's say we have negative 0.5. And let's say we have 0 and we have 2 and 5, just to make it nice and easy. Okay. So if x is negative 5, our y value is going to be 1 over negative 5, which is negative 0.2. If our x value is negative 2, 1 divided by negative 2 is going to be negative 0.5, negative 1/2. Okay. 1 divided by negative 0.5. Okay, 1 divided by negative 0.5 is going to give me negative 2. Okay, can't do 0. Let's do something else besides 0. Let's go negative 0.1. Okay, 1 divided by negative 0.1 is going to give me negative 10. Okay, now coming over here to this side, 1 divided by 2 is 0.5, and 1 divided by 5 is 0.2. So let's look at this graph here. I'm going to do it in red. So we have negative 5 and negative 0.2, which is right there. Okay. Next, we have negative 2 and negative 1/2, which is right there. And then we have negative 1/2, negative 2, which is right there. And we have negative 0.1, and then we have negative 10, really close to the or the y-axis. But we see what these points do. And I just chose those numbers. Off the top of my head, you could choose any x value you want that's not 0, and take 1 over that x value to get y. Okay. And when we come to the other side here, we have 2.5, and we have 5.2. And as these numbers, as we divide by smaller numbers, we talked about this in class today, this thing's going to sort of shoot up like that. Okay, and that's what your graph's going to look like. Okay, so the graph, guys, is just a set of points. Choose any x value you want that is good for the domain. Okay, and then run the math. Do whatever it is to the x value that the function's telling you to do. You're going to get points. You plot the points. Okay, typing it in the graph just does it all for us and gives us all the points in one line right there. Okay. So hopefully that kind of helps us a little bit. See me in class if you have any questions, but I'm hoping I can give you this to you to just sort of accelerate the process and sort of ensure that maybe we're getting the hang of this. Maybe we didn't understand this very well in Algebra 1, and maybe this wasn't explained to you, in the past very well. So hopefully, you know, I'm sort of breaking it down into what the little picture looks like. So maybe the big picture makes a little bit more sense to you guys. Okay. Let me know if you have any questions, and you guys take care and have a good night.